Hi there, this is Clint Mason with Guys and Well Solutions. Thought I would, as prices have increased, oil and gas, a lot of the older stripper type wells are being reactivated, and you're seeing a lot of these lower pressure um, applications of plunger lift start to come back online. For years, most of the focus was on shale and higher pressure, higher volume wells. And this issue we're going to talk about, which is threaded lubricators and some of the damage and issues with threaded lubricators, was not really a big priority in the industry here in North America, at least where we worked. So I thought I'd pull this up again. It's an old presentation that I did on identifying damage to the threads and what's causing it and a few things to look for. So we'll just go through that and see where we go. So lubricator thread failure and what can cause it. Well, really, it's pretty. There's a couple things that are happening. Um, Basically, the threaded lubricator has been kind of the main product of choice for plunger lift optimization for over 60 years. There's likely tens of thousands of these threaded lubricators in service today. I bet you there's probably thousands that are being reactivated with prices increasing. Um, One of the things that we found is not a lot of attention was given to them, and we would start doing inspections, and we'd find a lot of significantly damaged lubricators, and understanding why they're being damaged is important. So there's typically three things that we've found that result in lubricator failing. Obviously, the first failure that might come to mind is that single real high energy impact, which is usually caused by a combination of, your top spring um, is damaged, so there's no absorption there, and somebody has taken the well to atmosphere to unload it, or there's a hydrate that forms and they pull it to atmosphere, and you get these extremely high velocities resulting in really, really super high kinetic energies being put into the lubricator, which can stretch and damage the lubricator. Um, One of the major, and typically, when I talk about hydrate, I'm talking about a true hydrate, not ice. And hydrates can form um, in the right conditions, certain pressures, certain mixtures of uh, hydrocarbons and water and pressure, and it doesn't necessarily need to be cold outside, but temperature does, obviously impacts it as well. But we've seen quite a few failures that were caused by um, misdiagnosing a hydrate versus a well loading up, because they can look very similar. As a hydrate forms, the well starts flowing, it decreases, your flow rate starts to drop, your tubing pressure starts to drop, and your casing pressure will start to grow. So if you're looking at that information, it can look very, very similar to a well actually liquid loading. And then, your plunger gets hung up in the hydrate, stops running, the well shuts in, operator or pumper comes running out there and right away says, "Oh, well's loaded up." So, it used to be pretty common to pull a well to atmosphere. And if you pull a well to atmosphere, a couple things happen when you have a hydrate. First of all, as the pressure comes off, it starts to break apart and it will release from the tubing walls or whatever. And then you can have these, large. I mean, the hydrates could be, you know, 10 feet or 20 feet, 30 feet, 10 meters long, with basically a mass of ice and stuff with a plunger, and it can release with a tremendous amount of pressure underneath it and move very, very quickly. Because they're usually within a couple 100 feet of surface, and when they do release, it's just boom, and they go screaming into the wellhead, and it's, there's huge kinetic energy. Hundred can be hundreds of thousands of pounds. So that one's a pretty easy one to understand. If they hit, usually we see lubricators stripped off and things blown apart and stuff like that. So, anyways, that's kind of the number one. But one of the things what we're probably going to be looking at more is the repetitive damage and failure. And it's probably almost every threaded lubricator out there. I'm sure that if we went out and did this on, a high percentage of them you're going to find some stretching, some damage. And it's just the, the thread design and stuff, not really that strong. They're able to start to stretch even with fairly what I would consider reasonable impacts. But anyways, let's go through that. And especially if you're letting your deceleration spring or deceleration device be damaged where it's not absorbing some of that energy. That's why it's always in all my conversations, the key thing is always make sure that your deceleration device lubricator is in excellent shape. So what we're looking at here is basically this is a API thread gauge that's for an EUE thread. And what you can see is it's engaging here. And as we come down to the end of the thread, there's starting to be space and the threads are not lining up. So because the threads aren't lining up, that's telling me that somewhere along these threads, it is stretched. It's no longer matching that thread form. So because it's not matching that thread form somewhere, and usually it's the last thread that's engaged in the wellhead, for example, is going to have a stretch in it. In between the two threads, it's actually going to start to grow because that's the weakest spot in the whole lubricator is the last thread engaged, and it gets hit and it slowly stretches there. And as it stretches, it actually starts to collapse the OD of that thread, and it starts to deform that thread. And when you can slowly stretch over time, and you not even realize that it's failing, and then all of a sudden one hit too hard, too often, and they pop off or break. So that's one of the things you have to watch for. Here's another example. Now, these are all different manufacturers. I'm not saying that this is a manufacturing issue or anything. It's an inherent issue that comes with using UE threads in a plunger lift lubricator. They're not really designed for that impact. They do have pull strength and stuff, but they're not designed for that repetitive impact, especially when you don't have any, if your top spring has been damaged. Again, here's another example. You can see basically right here in this area, because if you look at how it's lined up, and then right here, there's interference between these, the gauge and the threads, and that's where it's stretching. So this is probably where that thread was last engaged into the wellhead, and it's stretched right at this point. Another example, here's a last thread engaged, and it's actually stretched and started to pull things out of the line and created those same issues. Here's a pretty example of where you can see how it's really been stretched out and damaged. Same thing, last thread engaged, and it's way out of line here, and loss of stretching. So that's becoming quite weak. Now, again, these are multiple manufacturers, not one particular manufacturer, and you can see again, last thread engaged, it starts to stretch. The other thing that we see when we do this is we'll see a lot of damage on the inside of the lubricator. Now, why is that? What you'll notice is that if you look at where your outlet is on your floaty, so if you put that lubricator on top of the wellhead and left the floaty in place, and if you're flowing through that floaty, gas is flowing out, that plunger is going to hit on that one side repeatedly right where the floaty is. And it's pretty easy to understand why, because basically, and there'll be a little animation coming up that shows that every time the plunger goes into the floaty, and it's much bigger than your tubing drift, for example, it actually pulls that plunger to that side where the floaty is, and then it runs up the side and hits right into the bottom edge of that lubricator and damages. So when that happens, what you'll see is you start to also damage the floaty itself, or what you're threaded into, and it'll start to stretch it, egg it, create all sorts of issues, and you'll start to see leaks and stuff there. And we'll come out and see lots of lubricators that are leaking between that connection, and they people don't realize why it's happening, but it's happening because there's a definite damage. And you can see in this case, we tried to pull this lubricator off, and it actually galled the threads. It was so stretched so bad, and also damaged the threads inside the wellhead or on the floaty. We ended up replacing all of that when we tore it apart, and so that was a fairly expensive repair job. Another example of a UV stretch. So just pop through that. So in this animation, it kind of explains what's happening. So if we're flowing out of the floaty, out of this part here, and we have our lubricator on top, and it's pretty common to put, a single outlet lubricator on and we leave the floaty in place. Well, that flow that comes out of here pulls that plunger over and it just hammers right into the bottom edge of that lubricator. Even if it's tapered or whatever, there's always a part and it just keeps pounding on that. And I've seen them where it's pounded them so thin that they've split right on the outside. It's just basically pounded it out. And then you'll see it hits here, then it bounces across and hits over here, and you'll get these damaged spots here, damaged spots here. So the easiest way to correct that is, number one, don't flow through that floaty, leave the valve closed. Now that creates some issues because if you have a single port outlet, what you're going to have is a plunger that sits in the flow all the time, causing a restriction, which you don't want. So the real solution is actually to come in there and remove the floaty. And when you do the initial installation, you take the floaty out, you tie a dual outlet lubricator in place and tie it back into line. And if it's built properly, the lubricator, it should line up pretty good. You might have to add a few nipples or whatever, but you shouldn't have to do a whole bunch of work um, to put that lubricator in properly. This is not a problem with flanged wellheads, by the way. It's only a threaded issue when you. So if as long as your lubricator was flanged and your master valve was flanged and or your flow T is flanged, it's going to be a much less of an issue because you don't have that thread inside that's going to stick out there to be hit with a plunger every time. So here we have an example. We've taken the flow T out. Now we have both our um, uh, valves hooked up on the lubricator, and now there's none of that. The change of direction that's going to pull that plunger over happens after the plunger's in the lubricator, so you don't have anything for it to hit. It just slides up and then hits your deceleration device or your spring at surface. So we know that when we inspect fields that use this type of plunger lift equipment, we find a huge number. Now, if we've gone to a field that hasn't been inspected, say in 4 or 5 years, we'll see 70–80% of the lubricators will not pass a thread gauge. Um, um, typically, if they're stretched that much, you probably should replace them because it's becoming weak. Um, the damage is not typically present when we inspect a field with properly installed lubricators. That's the other thing. So if the floaties have been taken out, lubricators, we actually find that that damage is almost non-existent. We don't see any damage. We don't have the same problems. All we got to worry about then is issues like corrosion issues. Methanol. I've seen methanol that because it's an oxidizer will cut and damage the lubricator where it's being injected. Maybe H2S, CO2, even if it is the proper material, it can create some issues. I can tell you this, for the little bit of money of tying a lubricator in properly, it will save you money over the long time because I've seen many lubricators actually, what they've been put in improperly, um, that are damaged within months. And 1 year or 2 years, they're basically need to be replaced because of that. So if you want to save that, spend a few extra dollars, take the flow T out, or use a flange. And to be honest, I would always recommend a flange connection anyways, would always be the way I would go if it's possible. But some people don't have that. They got threaded wellheads. If you take that flow T out and tie in your dual outlet lubricator properly, you're going to minimize a lot of the issues with the damage you see in these plunger lift lubricator bodies. Low temperature, other damages, low temperature and hydrogen sulfides. Well, you got to make sure you use the right material. Um, Typically, you want a material that's less than 22 Rockwell, a 4130, 4140 should have a real decent tensile strength. We typically look at about 96,000. There's a lot of people that use um, inferior material. Unfortunately, it could be called 4140 or it is 4140, but it doesn't necessarily have that Rockwell that you're looking, or the Rockwell to be good for hydrogen sulfides or low temperature. And a lot of the countries, low temperature doesn't matter, but hydrogen sulfide or H2S is going to cause issues. So you want to have that Rockwell less than 22, but then there's also 4140 and 4130 material that can have a tensile strength that can be significantly below that 96,000. So it's important when you're talking to your supplier to check out all the material uh, information and mechanical properties. This impact on the bottom of the lubricators can also be seen on your plungers many times. And if you're pulling your plungers and you're inspecting them, if you look at the very top outer edge of the uh, plunger, many times you'll see an impact mark all the way around that outer edge of the plunger, about a quarter-inch in. And sometimes that's mistakenly, credited to tight collars or going through the wellhead, like the hanger or something. But most times that's not the case. Most times it's going to be a result of it hitting the bottom of the lubricator. So if you see this when you pull plungers out, it's a good idea to pull that lubricator out and inspect it to see what kind of damage is happening to that lubricator itself. Again, I can't really stress this enough. If you have a choice and if your wellhead is flanged, just stay with a flange bottom lubricator. Your outlets can be threaded, whatever you want, but if that flange connection will last for years and years and years and years, like I mean, we've got lots of flange lubricators out there that are probably 25 years old or more, and and as good a shape as the day they went in, So I highly recommend that you always go with flanged. I would also recommend your wellheads are flanged for plunger lift, especially 2 3/8. But I know we got to work with what we have out there, and if you are using threaded lubricators and threaded wellheads, you just need to be aware of the damage and make sure that they're properly inspected so you don't have a mishap out there. So, anyways, I don't have too much more to talk about here. I appreciate you taking the time to watch this. Hopefully, there's some useful information. If you are running a lot of those threaded lubricators, keep an eye on that. One other thing is if they're starting to leak around the threads and you see oil or gas coming out of there, it's probably another good reason to do an inspection. I would not recommend you grab a pipe wrench and just try to torque it down again. I would suggest you take pressure off, remove it, and do an inspection and then reinstall it. One last thing also on an EUE thread, never use thread tape. It should only be put together with proper uh, thread dope, pipe dope, and that is designed for an EUE thread. When you do put thread tape in there, it actually interferes with the thread engagement and makes that connection weaker. So if you need thread tape to make the connection seal, you probably have something wrong with the connection. Anyways, have a great day. Thank you. Take care.